Hello friends, in our previous video we solved a problem in cantilever. The cantilever beam was carrying uniformly distributed load throughout its length. In this video we are going to see this problem. We are going to solve this problem where the UDL is not spread throughout the length, but it is spread partly. Now let us solve this problem. So now in this problem, how many segments we can divide? We can divide this into two segments. So I will name it A, B, C. So CB is one segment and AC is another segment. So I come from this end, I take a section X, first shear force between CB, Vx equal to, now this UDL 2 kilonewton per meter, we have to change into a point load. It will be acting mid of X, right, and 2 is the force, X is the distance, 2x is the point load that is acting here. So to the right, downward is positive, so 2x is the force and it is linear. So at x equal to 0, VB equal to 0. At x equal to 2 meter, I am at C, so VC equal to 2 into 2, 4 kilonewton. Right? Now bending moment. Let me find bending moment also. So in CB section, Mx equal to, this force about the section will produce a clockwise moment. The perpendicular distance is x by 2. So minus 2x into x by 2. So minus 2x square by, so I'll write here, minus this 2 gets cancelled, x square, it is a parabolic variation. So at x equal to 0, MB equal to 0, at x equal to 2 meters, I am at C, 2 square minus 4 kilonewton meter. Right? Now to the second segment. So I will erase all this. Now I will pass the section here. See here, once we crossed C, the entire UDL is up to 2 meters only. So now I can change the entire UDL into a point load. 2 into 2, it will be acting at mid, so 4 kilonewton. So now I have passed the section. It is X distance from free end. Right. Now between AC, shear force, I have only one force, that is 4 kilonewton. In other words, whatever force at C is acting will be acting between AC because there is no other load. So it's going to be constant. So Vx equal to 4 kilonewton, it's a constant. So between AC, shear forces constant. So now we will find out the bending moment. in the segment AC, mx equal to, what is this distance? 1. Okay, so x minus 1 is this distance. So force into perpendicular distance, clockwise moment, so it's going to be negative 4 into this distance is x minus 1, and it's a linear function at, what is the boundary condition? 2 meter to x equal to 3 meters. So at x equal to 2 meter, I am at C, so 2 minus 1, 1, so minus 4, it is already found, 4 kilonewton meter. At x equal to 3 meter, I am at A, so 3 minus 2, 2, minus 8 kilonewton meter. Now let me draw the bending, shear force and bending moment diagrams. So I will extend this, also extend this, and also draw this. So it's going to be positive, so A, B, C. So you know dV by dx equal to minus W. You have uniformly distributed load, it's constant between CB. So the slope in shear force diagram is going to be constant. So to here, see here, 0, 4. The variation is linear. It is a straight line. The value here is 4 kilonewton. And between AC, it is constant, and it is going to be 4 kilonewton. This is your shear force diagram. Now coming to bending moment diagram, AB, C. At B we have 0, at C minus 4, the variation is parabolic, and minus 8, it is linear. So 0, and the variation is going to be parabolic. So it is parabolic curve, and the value here is 4 kilonewton meter, it is negative. So when you have a linear variation in shear force, we have a parabolic variation in bending moment diagram. You can look at this relation. So when V is actually increasing, the slope will also change, right? So this value, shear force, is increasing, so the slope is also changing and keep increasing. Yeah. And here in shear force AC, it is constant, so it will be a straight line. It's a straight line. And the value here is 8 kilonewton meter. I hope you would have understood now how to divide the given beam into segment, how to write the expression for the different segments based on the external force, whether it is point load or distributed load, right? And then you have understood Using these relations, how to draw shear force and bending moment diagrams. Next video, we will solve little more complex problem, which is a cantilever beam carrying combined loads, that is point loads and uniformly distributed load. If you have any doubt, mail me or contact me through the number which is given in the description, or leave a comment in the comments box. Thank you.